Okay, so the second part of joining the world of DeFi is to really understand some of the big picture in terms of the technology, in terms of the crypto space. So I'll go through a number of concepts and at a fairly high level to give you an idea of what is actually going on. So for example, we talked about cryptographic hashes to some degree. We talked about keys. We've talked about addresses. I'm going to layer on a little more detail, which I think is important for you to understand. So we started very early on to talk about a hash. So I want to make sure that you understand in the first course, we talked about SHA-256 hash, which is used in Bitcoin. And that takes an arbitrary size input, and the output is 256 bits or 64 hexadecimal characters. Ethereum uses the KCAC 256, and that is basically in the SHA-3 family. So it's a more advanced hashing algorithm. These are cryptographic functions, but they're not encryption. They're one-way functions. Okay, so this is really important. If somebody says that a hash is encrypting a document, they don't understand the basics, and you need to understand the basics. So this is a one-way function. It's not meant to be undone, and it plays a very important role in all of these blockchain protocols. So a hashing function is number one. So cryptography is important in terms of what we do, in particular in terms of the private and public keys. So just so you know, this field is actually broken into two branches. So cryptology is the general area. Cryptography is what we focus on, and that's basically the science of making stuff secret. So your private key is secret. Cryptanalysis is kind of the reverse. So that is decrypting stuff. And we don't really talk about that in this course. It's a cryptography that is the most important, and it makes the blockchain technology that underlies Ethereum very powerful. So in terms of cryptography, there's two different types of cryptography at a very high level. And one is symmetric key, and the other is asymmetric key. So let me tell you briefly what that means. So think about encrypting a document. So it might be like an Adobe PDF where you password protect that document. And then you send that document to somebody and then somehow let them know what the decryption key actually is, the password. Okay, so that is an example of symmetric key cryptography. So it's the same key that's used to encrypt and decrypt. However, most of what we do in blockchain technology has to do with asymmetric key cryptography. Okay, so think of a private key and a public key. And the public key is mathematically linked to the private key. The private key is a random number. The public key is derived mathematically, but is derived in a way that makes it really difficult to go from the public key to the private key. But it's really easy to go from the private key to the public key. Okay, so the methods that we use to do that are called elliptic curve cryptography, or ECC. And when we talk about signatures, we're going to be using elliptic curve cryptography also. Okay, so let's kind of give some examples of this so you get the idea. So, and this is public and private key with asymmetric keys. So a message needs to go from a sender to a receiver. So think about the receiver gives the sender a lock physically. Think about it, a lock. So the sender locks the message and transmits it to the receiver. Only the receiver can open the message because the receiver has got the key to the lock. Okay, so the sender can lock the message, but there's no ability to unlock it. So it's basic intuition as to how this works. And the lock is basically the public key, and we will open it with the receiver's private key. This is an example of my business card, by the way. And notice at the bottom of my business card is a key. Okay, so this allows people to encrypt an email with my public key. And only I can decrypt the email because only I have the private key that's associated with that public key. Okay, so this is a very important application, and this is a bit of a digression, but it's important for you. So let me give you an example of PGP email. So this is how it works, and it's interesting. It uses both symmetric and asymmetric encryption. So the way it works is the following. You start out compressing the message to reduce the size. That's no big deal. And then a random number is generated. It's called a session key, and it's usually based upon mouse movement. So it's unique. It's a random number. And that is going to be your symmetric key. Okay, so that is going to be something that we're going to use because we're going to take the message. So the sender is going to encrypt the message with that private symmetric key. Okay, then the next step is that session key is encrypted with the receiver's public key. Okay, so that's asymmetric. So then the encrypted message and the encrypted session key are sent by email. The recipient uses their private key to decrypt the session key, and then the session key is used to decrypt the message, and then you uncompress. So this uses both symmetric cryptography and asymmetric, and very straightforward to do. So again, this is foundational material that we use in blockchain technology.